to show how I transformed a real client requirement into a working financial intelligence dashboard using AI-assisted development. I will focus on the process, how I planned the system, built the backend and frontend, tested it, and turned complex data into something the client can actually use. All the information shown in this video is either anonymized or based on a mock account. This image gives a simplified overview of the complete project. The client needed a clearer way to understand financial activity, historical performance, and risk across different accounts. So my job was to translate those business requirements into a reliable technical system. So the process starts on the left with a read-only financial data source. Read-only is an important part of the design because the system can collect and analyze information, but it cannot place trades, withdraws funds, or transfer money. So this was very important because of security and other things. Therefore, the data is collected automatically at the regular intervals and stored as historical snapshots. Then in the backend, I created the logic that processes this information, validates it, and calculates the metrics required by the client. This includes account value, profit and loss, historical performance, risk, and data freshness. PostgreSQL acts as the central source of truth. The frontend does not invent information or calculate random values independently. It receives processed and validated data from the backend. So on the right, the frontend transforms the information into a visual dashboard that is very easy for the client to understand and investigate. At the bottom, you can see how I work. I use GitHub as the source of truth for the project. I use AI to support planning, implementation, testing, and review. And then I use a remote VPS to run the backend, the database, and the automated processes. AI helps me move faster throughout the project, but I'm still responsible for the architecture, requirements, security decisions, testing, and final verification. Now I want to show you how this workflow becomes a real working product. This is the actual dashboard. For this demonstration, I'm using a mock account that is not connected to any client data. It contains no financial values, but it allows me to safely show the structure of the system and the information it is prepared to process. At the top, we can see the main data flow. The information comes from a read-only source, which is Binance. The backend collects it. PostgreSQL stores the historical snapshot, and the dashboard visualizes the processed results. We can also see the current system states, such as whether the backend is online, whether snapshots are being stored, and how frequently the information is collected. So we have these tabs: Overview, Performance, Activity Reports, and Technical. In the Overview section, we have the main information requested by the client. It includes account value, profit, and loss, current and maximum drawdown, balance, open equity, and open positions. I'm not going to explain every financial concept in detail because the important point here is the workflow. The backend collects and processes the information, and the frontend presents the result in a clear and organized way. Because this mock account has no historical data, the system does not generate fake results. Instead, it clearly says that there is insufficient information. This was also part of the design. When the system does not have enough evidence, it should communicate that honestly rather than displaying an unreliable number. Then, in the performance section, we have a system which is prepared to display more detailed analytics, including close position statistics, win rate, average results, expectancies, and other risk information. Some of these calculations require additional historical information. Again, when that information is not available, The dashboard marks it as pending rather than estimating it. Then in the activity section, which is designed to show account and position activity over time. It separates information such as balance, unrealized profit and loss, and account value, so the user can understand what is changing. Then in reports section, this one brings together the information needed for more formal analysis. This includes investor summaries, account reconciliation, cash flow classification, monthly performance, drawdown analysis, and exportable reports. The objective is to transform the data stored by the backend into information that can also be reviewed or shared outside the dashboard. Finally, in the technical section, this one helps us verify that the system is operating. It includes monitoring coverage, storage information, data freshness, and runtime health. This is useful because the dashboard does not only show financial results, it also shows whether the underlying data and infrastructure are working as expected. So this mock account allows me to demonstrate the complete structure without exposing any real client information. Now we can see an example of the system with information available. This view was created to give the client a clear overview of how the account has changed during a selected period. It brings together the account value, balance, historical high point, and drawdown in one visual area. The user can change the period between 1 day, 1 week, 1 month, 3 months, and so on. That was an important client requirement because the same information can have a different meaning depending on the time period being analyzed. The interface also shows the current account state and the freshness of the data, so the user can see both the result and how recently the underlying information was updated. The data shown here has been anonymized and should only be understood as a demonstration of the functionality. The second example is the portfolio history view. This allows the user to investigate the historical data in more detail. The first option is Change from Start. This shows how the account has moved from the beginning of the selected period rather than only displaying the current value. The user can change between 1 day, 1 week, 1 month, and so on. Sometimes we can see some gaps here because I was stopping the system to update it, the whole architecture, or making some upgrades, and so on. Yeah. The chart updates according to the selected time range, using the historical snapshot already processed and stored by the backend. The user can also zoom into a specific part of the timeline and move through the historical information. This makes it easier to investigate a particular change without losing the context of the complete period. Then we have the NAV candles. The same data can also be presented through this. This gives the user another way to inspect how the account value changes between different intervals, and the important point is that these are not separate or disconnected calculations. Both visualizations use the same stored and validated backend data. The frontend simply gives the client different ways to understand it. Throughout the project, AI supported each stage of my workflow. So, it helped me analyze requirements, plan the architecture, implement parts of the backend and frontend, create tests, review the results, and document the system. But AI was not simply given control of the project. Every important result still needed to be tested and verified. I tested the backend logic, the financial calculation, the API responses, and the different frontend states. I also verified how the interface behaved when data was available, delayed, incomplete, or missing. This is how I use AI in real projects, not only to generate code, but to support a structured process from business requirement to tested implementation. So I started with a client requirement, translated it into a technical architecture, built the backend and frontend, connected the different parts and tested the complete system. So as you know, we had the whole process from Binance with a read-only API key. Then I collected the whole data. Then I used PostgreSQL to save all the information, and then in the VPS I process all the data and then show in the front-end dashboard. So for this whole process, AI accelerated the whole of it: architecture, testing, and human judgement, which was very useful to make it reliable. Then from the very beginning, I had in my mind the security regarding the read-only API access, no trading and no transfers, and then analyze and never control and never touch the money from Binance.